Friends. Good evening,
Good evening,
students.
sir.
Good
Good
evening,
evening,
beta.
sir.
Good evening, beta. So, in the last class, I was discussing different aspects of the circular motion. Now, this is non-uniform circular motion I was discussing. Non-uniform circular motion. Circular motion. So basically, in case of non-uniform circular motion, if you look at non-uniform circular motion, speed changes. Speed of the particle changes. Speed of the particle changes here. Particle changes. Okay. So in the last class, I have shown you that vertical circular motion is one of the best example of non-uniform circular motion. So vertical circular motion. Vertical circular motion is the best example of non-uniform circular motion. Okay, here in the last class I have shown you how the weight, okay na, for the half of the cycle a component of the weight is anti-parallel to the velocity. As a result, speed decreases. And that half part of the circular motion, vertical circular motion, that undergo retardation. ठीक है ना? That is a retardation zone. For the rest half of the cycle, a component of the weight of the mass undergoing circular motion, it is in the direction of the velocity. So basically that will provide a positive acceleration and speed is going to increase. So half of the vertical circular motion is under retardation zone and half of the vertical circular motion is in the accelerated zone. So now what will be the acceleration? Okay, in polar coordinates, we know what is the expression of acceleration here. Acceleration कितना होगा बेटा? So here, if you look at the acceleration in case of non-uniform circular motion, so A कितना होता है? बताओ. What is the expression of A? That will be in polar coordinate. That will be r double dot minus r theta dot square. ठीक है? R theta dot square. This will be r cap. ठीक है ना? This will be r cap plus, ठीक है, r theta double dot plus 2 times r dot theta dot, and this will be theta cap. ठीक है ना? So basically this is the expression of the acceleration in polar coordinates. ठीक है? Is it okay बेटा? याद है सभी को? So here, if this is a circular motion, then this radius r, it will be equal to capital R. This is a constant. This is a constant. So what will be r dot? R dot will be 0, as well as r double dot. This will also be 0. 0. So here you can write this r dot, that is going to be 0. And second, okay, second this r double dot, it is going to be 0. Okay, r double dot, that is going to 0. But this time remember this, the angular velocity, that is not constant. So try to understand why angular velocity is not constant. You are saying that speed is not constant. You are saying speed is not constant. When speed is not constant, speed is how much? That will be r omega. So that will be r omega here in case of circular motion. So r omega is not constant. But r itself is a constant, radius is fixed. So radius is fixed means omega is changing. Then who is changing? If this quantity is not constant, it means omega is variable. Omega is changing this time. So what is omega? Omega is theta dot. Omega is equal to theta dot, and this is not constant. This is not constant. Very similar to the speed. So that's why now theta dot is not constant. So this theta double dot, it will not be 0. So this time, both the components r cap as well as theta cap, they will survive. So here, what will be the acceleration in case of non-uniform circular motion? One will be the same. This will be r theta dot square. Theta dot square. This will be r cap. And second, this will be plus r theta double dot. And this will be theta cap. Theta cap. So this is the acceleration, this part, this is in radial direction. This is the acceleration in the radial direction and we call it a centripetal acceleration. And this is the tangential acceleration. We call it as AT or A theta. Okay? We call it as AT or A theta. Particularly in case of circular motion, we call it as tangential acceleration, but in another cases, you can also write it as A theta. So this will be A. So two type of accelerations are there. Radial acceleration will be there, that will be inward minus r theta dot square, or you can say that this will be r omega square. Okay? Or I can also write it as minus v tangential square upon r. This will be. Okay? Here this radius r, this is capital R, you can write here. So there will be a radial component of the tangent, this acceleration, and that is acting inward, and you call it as centripetal acceleration. What you call it? This is called as centripetal acceleration. This is acting toward the center. So this acceleration is always acting toward the center. This is called as centripetal acceleration. Centripetal acceleration. But this time there is one more acceleration, that is tangential acceleration, AT. And how much it is? It is r theta double dot. And what is r theta double dot, if you remember? Okay? If theta dot is omega, then you know that d omega, this omega is how much? This is d theta by dt. D theta by dt. If you further differentiate this, this will be theta double dot, or you call it as d omega by dt, or you call it as d square theta by dt square. And this is called as angular acceleration. You call it as alpha. So this is called as angular acceleration here. So this is angular velocity and angular acceleration. So here this alpha is there. What you call it as? This is called as angular acceleration. Angular acceleration. So tangential acceleration is r times, okay, this is radius r times theta double dot, or you can say this is r alpha beta.
सर
Yes beta, please.
सर वो डी थीटा बाय डी थीटा एक बार समझा दीजिएगा.
This is theta dot. Theta dot is what? D theta by dt. You have to, this should be t na. This is not d theta by d theta. This is d theta by dt beta.
Okay sir,
d
thank you.
square theta by dt square. ठीक है? Angular velocity is d theta by dt. ठीक है? Angular velocity is d theta by dt. So this will be. So here two type of accelerations are there. So in case of non-uniform circular motion, not only centripetal acceleration is there, but there will be a tangential acceleration. How much this tangential acceleration will be? That will be r alpha. That will be r alpha. So in non-uniform
Sir, can you
circular,
please show the previous slide?
just 1 second beta. Non-uniform circular motion, basically two type of accelerations are there. So two type of accelerations will be there. Acceleration means meter per second square unit. ठीक है? Meter per second square unit acceleration. So one is centripetal acceleration. centripetal, that is acting toward the center. Centripetal acceleration. And second is tangential acceleration. Tangential acceleration. Acceleration. This centripetal acceleration, this is AC, or you can say this as AR. So AR, this is called as centripetal acceleration. This is minus, remember this is V tangential square upon, ठीक है ना, upon R. And this will be AT, and how much it will be? That will be R times alpha. This will be R times alpha. So two type of accelerations are acting here. One is this. So here, if this type of vertical circular motion is there, then at any position of this particle here, this is the particle, its mass is m. It is undergoing this circular, vertical circular motion. So throughout its motion, one will be here. ठीक है ना? One, this will be AC, that is acting. Okay, this is the acceleration. Now, if this is the upper part, so here speed is going to decrease. So velocity is here. Try to understand. This will be Vt. Okay, Vt is there. So this acceleration, it is going to act in this direction. This will be how much? This will be R alpha. They are in opposite direction. This tangential acceleration, At. Try to understand here, direction of this velocity Vt and this At, they are in opposite direction. So this At and Vt, they are in opposite direction. That's why for this half cycle, this will be retardation. This will be retardation. But if you look at here, then in this situation, tangential velocity will be here, Vt will be here in this direction, and this acceleration, that will also be here in this direction. So this will be R alpha. This should be R alpha. So here, basically, this is accelerating zone. So here, try to understand for this half cycle, velocity and acceleration, they are in opposite direction. They are in opposite direction. So this is a retarding zone, as I have discussed in the last class. Retarding zone. And here, this is accelerating zone, this side.
In the accelerating zone, Vt and the R alpha is the same direction.
They are in the same direction. Acceleration means when you are going to have acceleration only in two situations, if V and T, try to understand. ठीक है? V and A, sorry, not T. If V is positive, means in the same direction, this A is positive. Or both are negative. Here, this will be. Means V is negative as well as A is negative. So in both these cases, acceleration will be there. Acceleration doesn't mean A is positive. For the acceleration, it is necessary that velocity means motion and acceleration, they should be in the same direction. So if this situation is there, either this or this, then you are going to have the acceleration. Acceleration. So this is the condition of acceleration. When it will be retardation, for retardation, it is necessary that velocity and acceleration, they will be in opposite direction. So if it is positive, then acceleration should be negative. Okay? Then acceleration should be negative. And here, if it is here, it will be here. So this may be the situation. V is negative here, then A is positive. But here in this case, of circular motion, it is just important if velocity and acceleration, they are opposite, then force corresponding to this acceleration, some force will be responsible for this acceleration. Try to understand, surely there will be some force that is acting in this direction, which is responsible for this. That force is opposing this motion. Particle is moving up. Basically, a component of the weight is opposing this motion. So that is going to give a retardation. ठीक है ना? So this basically this is opposite to V, so this is a retarding zone. Here component of weight is here parallel to VT, so this will be the accelerating zone. So this is the way, this is retardation. This is called as retardation. So for retardation, velocity and acceleration, they should be opposite. For acceleration, velocity and acceleration, they should be in the same direction. ठीक है ना? They should be in the same direction. So here this plus and minus, it was just to show you. ठीक है ना? But here you just can remember velocity and acceleration when they are in the same direction, there will be accelerating zone, and when velocity and acceleration they are in the opposite direction, that will be a retarding zone. So for the non-uniform circular motion, two aspects will be there, two type of acceleration will be there, and velocity, one type of velocity will be there, only tangential velocity will be there here. Tangential velocity, beta. There will be only one velocity, that will be tangential velocity. Why tangential velocity? Because V is equal to, in polar coordinate, that will be r dot r cap plus r capital R theta dot theta cap. So this will be 0 here, only r theta dot. So this V is equal to r theta dot theta cap. So what is this? This is tangential component. So Vt is equal to r theta dot or r omega. So two type of acceleration and one type of velocity, ठीक है ना? They are must for the non-uniform circular motion. So here Vt will be there, that will be r omega. So remember this. This will be. So this is the situation for non-uniform circular motion. So here, if you look at why this speed is changing, because a force in the form of weight is acting. That's why, because continuously a force is applied, ठीक है ना, whose component is parallel or anti-parallel, that's why speed is changing. That's why speed is changing. And if you look at the weight, ठीक है ना, weight will act in this downward direction, so there will be a torque about this point O. There will be a torque that is continuously acting on this particle. So that's why omega is changing. So omega is changing as well as speed is changing. Why speed is changing? Because a continuously a force in the form of weight is acting. That's why basically this speed is continuously changing. Why omega is changing? Omega is changing because a torque is non-zero. Always a torque is acting. ठीक है ना, ये जो weight है ना, this weight is acting in the downward, so it is going to create a torque here with respect to this point O. About this point O, it is going to create a torque. So that's why basically omega is also changing. So omega jo hai, that is also changing. So omega as well as speed, both are changing in case of non-uniform circular motion. Is it clear to everyone what I am saying? I have shared a sheet of questions of polar coordinates with you. ठीक है ना? Have you seen? Have you received that?
Yes.
Yes, sir.
Sir.
So you have to solve that sheet. ठीक है ना? आपको, you have to try to solve those questions. Now, last part of this polar and circular, polar coordinates and circular motion is, suppose this is the last part of this section. Suppose a mass is undergoing vertical circular motion. So here, vertical circular motion. Vertical circular motion. Circular motion. So here, this is the mass, ठीक है ना, that is undergoing this motion. So here, if you look at weight, and this is the vertical line passing through the center. So this is the lowest position, and this is the highest position. Suppose this angle is theta. Theta. then weight of it is acting in the downward direction. That will be mg. And a component of the mg will be along this. So this will be theta here. So this will be mg cos theta. How much it will be? This will be mg cos theta. And here I am assuming that one end of this string here, this mass is attached with a string. One end of the string is attached with this mass and other end is fixed here at point O. And this string is helping this mass M to undergo vertical circular motion. So because the string is here, so a tension is going to act here. Tension is always having a pulling effect. So on this mass, this tension is going to pull. So on this mass, tension is going to act in this direction. Tension is always having a pulling effect. Now, what is the source of here? If you look, what is the source of centripetal force? Because circular motion is taking place. So there should be some source of centripetal force. This component will be mg sin theta. Bolo beta. What is the source of? So here tension is the source. So it will be tension that is acting as a source of centripetal force, but there is a opposite force also, mg cos theta. So T minus mg cos theta. This is the source together. This is the source of centripetal force. So that will be mv square upon r. Okay, so here for circular motion, it is needed that there should be some source of the centripetal force. So who is acting? Tension is acting inward. So it can be a source of centripetal force. But from this T, you have to subtract this opposite direction force, mg cos theta. So this tension T will be mv square upon r plus this will be mg cos theta. Mg cos theta. This is the highest point. I call it as a H. This is the highest point H. Okay. So if you want that you are providing some velocity to this mass here, and you want that this should complete the cycle. Okay. You want that this mass should complete this cycle. So this process in which this mass is completing the cycle, that is called as looping of loop. This process is called as looping of the loop. Means it is undergoing complete cycles. This mass is undergoing complete cycles. So that process is called as looping of loop. Then when it is completing its cycle, then it is called as looping of loop. This is a term that is used here. Now, what do you want when this mass is at the highest point? If you want that this looping of loop should take place, what should be there here? What should be the condition at the highest point? At highest point for looping of loop H, what should be there? Only one condition should be there, that ये जो string है ना, that string should not be loosened. ये lose नहीं होना चाहिए. So for this 2t should be greater than 0. So condition is at highest point, ठीक है ना, at h point th, it should be greater than 0. So what it should be greater than 0. So at the highest point, this th should be greater than 0. And at highest point, what will be theta? If you look at this theta कितना होगा at highest point? That will be 180 degree. That will be 180 degrees. So in place of th, substitute here this. So this will be mvh square upon r, and this will be cos 180 degree. Cos 180 degree is -1. So this will be mg. This should be greater than 0. So m will cancel out, ठीक है ना? And vh, highest point, at the highest point, vh should be greater than square root of gr. So if you want the complete loops, if you want that this mass should undergo complete looping, then at this highest point, VH, it should be greater than square root of GR. And second, tension here at the highest point, it should not be 0. It should always be greater than 0. So these are the two conditions for the highest point, so that looping of loop is taking place. So this is the condition at the highest point. Now with the help of this condition at the highest point, we can find out the condition of the velocity as well as tension at the lowest point also. I call this point as a lowest point here. So here this is the lowest point. So what will happen at lowest point? So next, at the lowest point, lowest point L, what will be theta? Theta
Sir,
will be
please
0.
previous slide.
Okay, beta, just please look at this. So theta should be 0 here.
Okay, sir. Thank you.
Okay. So please try to understand what will be the difference between the potential energy at the highest point and the lowest point here. That will be, this is R and this is R. If I consider this as the reference level for the potential energy, if I'm saying this potential energy is 0 here, then what will be the potential energy at the highest point? That will be mg2r. So here, what will be the total energy? Total energy will be 1 by 2 m vh square plus mg2h. So what will be the energy at the highest point? That will be the kinetic energy corresponding to VH, and second, the potential energy, extra potential energy with respect to the lowest point. So apply the conservation of energy to find out the condition at the lowest point. At the lowest point L, theta will be 0. Theta is going to be 0, beta. So what I am going to say here, that at the highest point, kinetic energy will be 1 by 2 m vh square. Highest, this will be the kinetic energy. And extra potential energy with respect to the lowest point, that will be mg into 2r. And it will be equal to the kinetic energy at the lowest point. At lowest point, it will be m VL square. This will be, this will be conservation of energy principle. Kinetic energy plus potential energy, that remains same. Why it is remaining same? Why it is conserved? Because only one force is acting here. That is gravitational force. Gravitational force. External force is gravitational force, and that is conservative in nature. So potential energy, potential energy, that is going to be this total mechanical energy, not potential energy. Total mechanical energy will be conserved here. Now, what you are saying, that at the highest point, this VH square, VH square, this should be greater than or equal to this GR. Kitna? That will be GR. It
Sir,
was there.
total
Yes.
energy can be conserved due to gravitational force.
Total energy will be conserved. Total energy means mechanical energy. Mechanical energy means kinetic energy plus potential energy will be conserved. If particle is undergoing the conservative force, if particle is moving under the influence of a conservative force, then total mechanical energy will be conserved. So gravitational force, if you look at this, this will be a conservative force. This is a conservative force. So that's why here in this problem, mechanical energy is conserved. Mechanical energy means kinetic plus potential energy. Is it okay, beta? Hello. So this will be GR. At
Yes,
the
sir.
highest point, VH square it is greater than, ठीक है ना, VH square is always greater than this, ठीक है ना. So here this is VH square. So what can I do here? I'm writing this a little bit lower or here. I'm saying that VH square at the highest point, VH square is always greater than GR. So I apply this condition here. This VH square is greater than GR. So automatically this quantity, total quantity, that will be equal to 1 by 2 mgr. In place of VH, I write GR plus this 2 mgr. This will be. So this 1 by 2 mvl square will be greater than this. So here I can write 1 by 2 mvl square. That will be should be greater than or equal to, you can write here, equal to, और ये कितना हो जाएगा बेटा 5 by 2 mgr. This will be mgr. So 1 by this 2 will cancel out, m will cancel out. So what will be the velocity at the lowest point? That should be greater than or equal to 5gr. This should be 5gr. So at the lowest point, if you want to complete the loops, if you want that this particle should complete the loop, so we have to give a velocity at the lowest point that should be equal to this or greater than this. So velocity at the lowest point that should be given to the particle, that should be this one. Is it okay? ठीक है बेटा? So and at the lowest point, what will be the t? T कितना होगा? That will be mv L square upon R, ठीक है, plus this will be mg cos theta. Now theta is 0. At the lowest point theta is 0. So this will be just mg. So this will be mv L square upon R and इसका maximum value क्या है? That is 1. So this is mg. So basically at the lowest point, if you look at, this will be Tmax. Tmax, because here maximum value of cos theta is +1. So Tmax will be at the lowest point. Now this quantity VL square that is greater than this. So automatically you can write in this way that m by R, and in place of VL square, I can write 5gr. So this will be 5gr plus mg. So this R will cancel out. So this Tmax here, this Tmax, it should be greater than or equal to here 6gr. Yeah, 6 mg, not gr. This will be 6 mg.
सेंट्रीपिटल फोर्स को -9 कन्वेंशन क्यों नहीं दिया?
Where at any point you can look here. Look here. What will be at any arbitrary point? ठीक है, what it will be? This t will be here. mg is in this direction. So at the lowest point also, if you look, this will be t minus. So at the lowest point, if I write here, try to understand, this t will be here. mg, that is going to act in the downward direction. So t minus mg, t minus mg, this will be mvl square upon r. So what will be t? T will be mvl square upon r plus mg. So whatever I have used. ठीक है? I have used this one only. Is it clear, beta? So here,
Yes.
Tmax at the lowest point, this should be greater than 6 mg. So you have to remember these two expressions, that at the lowest point, given velocity should be greater than, so at this point, velocity, it should be greater than square root of 5gr. So if you look at TIFR papers, ठीक है, if you look at TIFR papers, many times they have asked question based on this. You will find out at least 3 or 4 questions which is based on this analysis. So you should understand this. And T max that is greater than or equal to 6 mg. It will be. So VL का value कितना होना चाहिए? That should be square root of 5 GL, and T max at the lowest point, it should be greater than or equal to 6 mg. Only then looping of loop will be completed. So these are the conditions that you have to remember always. Okay, in case of vertical circular motion, whatever acceleration I have told you. Okay, so here, for example, here in this case, this is AC and this is AT. Okay, na? So I'm using another color for you just for 1 second. One more thing is there. If just 1 second. So this is, so try to understand here, this is AC, this is AC, and this is AT. So AT is here. So 2 acceleration will be there. This is AC. So there will be a resultant acceleration in this case. This type of question also they ask. Then here there will be a resultant acceleration. If at this situation you are having, then resultant acceleration will be here. Resultant acceleration will be how much? What will be A? A will be, in case of circular motion, what will be A? A will be equal to, they are at 90 degree. AC and AT, they are at 90 degree. So this will be AC square plus this will be AT square. This will be the net acceleration beta. Here, this will be the direction. And now if you look here at this position, this is what? This is AT. This is the direction of AT. And at 90 degree to this will be AC. So this time, this will be the net acceleration. This will be the acceleration. But because AC and AT, this is AT. Because AC and AT, they are at 90 degree. So net acceleration, magnitude wise, this will be. So what is AC? AC किस पे depend करता है? AC is depending upon tangential velocity. This is tangential acceleration. Try to understand. And this is centripetal acceleration. So centripetal acceleration, it is depending upon tangential velocity. So don't forget this. Don't confuse with it. Okay, so centripetal acceleration is depending upon the tangential velocity. But its magnitude of the tangential velocity here. And this AT, this, it is depending upon R alpha. Okay, AT is depending upon the angular acceleration. And in both cases, on both sides, I have shown you that this A will be resultant acceleration in case of non-uniform circular motion. That will be square root of AC square plus AT square. So this is all about polar coordinate systems. It is all about circular motion, uniform, non-uniform circular motion. I have discussed each and every aspect of these motions. Okay, now you can solve any type of numericals, any type of
Can you show
questions.
last
Yes,
slide?
beta. Okay, beta. This is the last slide.
Sir, I have one question about T max.
Yes, beta.
सर टी मैक्स का जो इनइक्वालिटी है वो लेस देन और इक्वल टू नहीं होगा फॉर 6 mg?
कुछ उल्टा लिख दिया क्या मैंने?
हाँ
No, T max should be greater than this, na? देखो, try to understand VL. What you are saying about VL? VL is greater than or equal to 5 GL. So here on this side, this is VL. So if you replace this VL, try to understand if your expressions are same. Here VL square is replaced by 5 GL. Who is greater than? 5 GR is greater or this VL square? Look at this inequality. VL square is greater than or equal to this. So if you look at these two only, then this will be greater sign here. So I removed this, and in place of this, I'm using T max. So T max will be equal to this. It should be greater than or equal to 6
But
mg.
in previous slide, you write the sign less than and equal to, I think.
It may be possible. So if I'm not wrong, I have written correctly here. ठीक है ना? Is it okay? T max is greater than or equal to 6 mg. Same sign is there.
Yeah, okay, sir.
So can you please
Sir,
show the
slide
first slide?
Which one, beta? Fourth one.
First slide.
First slide.
Yes.
This is the first one. This is the first slide.
second, sir.
Sir, I
Okay,
have a
thank you.
question. In uniform motion, we consider a centripetal force as a minus mv square by r.
Pardon? In uniform circular
In
motion, there is a centripetal
motion, we
force
consider.
Vt square upon r. That is okay.
So, but
Cent-
sign we consider that minus in inward sign ना inward लेते हम sign
देखो,
तो
remember
minus
this,
mv.
many times we are writing this AC. ठीक है ना? We are just writing it as Vt square upon r. ठीक है? Many times you are writing like this, but it doesn't mean कि negative sign is there or not. It is always acting inward. But if you want to write in terms of direction, if you also want to consider it direction, what will be its direction? Its direction will be actually minus r cap. So minus I am writing here, and this will be r cap. So if you want to write in terms of vector form, then it will be inward. ठीक है ना? So minus r cap is there. But even if you are writing, you should keep in your mind that this AC is always acting toward the center. Either you are using negative sign or not. But it should be very clear that it is always acting toward the center. ठीक है?
Yes,
Is
sir.
it clear?
The first slide,
This is the third
Yes.
one.
so first slide, principal ones.
First, अभी तो दिखाया था बेटा. This is the first one. This is the first slide. Second slide. This is third slide. And this is fourth one. ठीक है? This is fourth one.
So in third slide, TH should be greater than or equal to 0, right?
TH should be
Greater than or equal to 0 or
not equal to. Equal होने से क्या होगा ना? Try to understand if tension is 0. ठीक है ना? TH it may be 0 also. ठीक है? You are correct to some extent. You are correct. It may be 0. ठीक है? So you can write like this. वैसे 0 से it should be like this. It should be equal. It may be 0 for instant. ठीक है? For instant it may be 0. You are okay. And this is fourth. Last one. ठीक है बेटा? And now I have shared 13 or 14 questions with you. ठीक है ना? These questions are there. Please try to solve all these questions. आज थोड़ा late हो गया बेटा. मैं थोड़ा late आया. ठीक है? So please try to solve these questions and I will discuss all those 13 questions
Sir,
in the next
एटॉमिक
class.
की क्लास कंप्लीट हो गई?
नहीं, atomic is already completed. I was discussing vibrational spectroscopy. So I will discuss on Sunday questions of the vibrational spectra. ठीक है? And after that, we will start discussing every Sunday. We will discuss then Raman spectroscopy and then laser. So they are not completed. But atomic physics is already completed. Molecular physics is going on. This Sunday, I am going to complete nuclear physics. And after that, in the morning slot, every Sunday, I will try to complete it as soon as possible. Beta. Okay,
But
beta. Any another query?
20 जुलाई वाला बैच है उसकी एटॉमिक सर रिकॉर्डेड ही देखनी पड़ेगी कि उसकी भी आप दोबारा रिस्टार्ट करोगे लेक्चर हो?
Please repeat.
सर जो 20 जुलाई वाला बैच है ना उसमें सर जो हमें एटॉमिक करनी पड़ेगी रिकॉर्डेड वीडियो से करनी पड़ेगी.
अभी कर लो. ठीक है ना? We will repeat it again. ठीक है? I will repeat. First, I will complete it and then I will repeat it again. After
Thank you.
completing molecular physics, for the time being, you can go through those lectures, and after completing molecular and laser, ठीक है ना, we will again repeat it. So don't worry.
Thank you very much, sir.
Welcome बेटा. चलिए बेटा, good night.
Thank you.
Welcome.
Thank you, sir.
Thank you, sir.
Welcome बेटा.
Thank you, sir.
Welcome बेटा.